Lesson R6 is about synthetic division. Synthetic division is a substitute for long division. It's a method we use when we have a divisor that is x plus a constant or x minus a constant. The actual form is x minus c, and so if you have x plus some constant, what we'll do is when we do the synthetic division, we will use a negative number for c, because a negative number here would make this addition. Okay? The first thing you do, and this is going to be kind of vague just reading it, but once we get into doing some examples, it'll make it a little simpler. First thing you're going to do is write the dividing, sorry, can't speak. Write the dividend in descending powers of x. For example, if you had a 2x minus 5x squared plus 3, you would put the negative 5x squared plus 2x plus 3. Put them in order, highest degree to lowest degree. Then you'll copy the coefficients into the usual division symbol. Remember to insert a 0 if there's any missing powers of x. The divisor outside the division symbol is c from the binomial divisor x minus c. So right back to what we said earlier, if your divisor is x plus something, you need to put a negative value for your c when you write it outside the division symbol. You bring down the first coefficient in the dividend 2 rows into the third row. Let me just do a little example. Well, I can't right now. I'm going to have to wait till we get down there. You're going to bring the first coefficient down. You're going to multiply it by the divisor, and then place the result directly below the next coefficient under the division symbol. You'll add those together, and it will create the next entry in your third row, and then you can continue to repeat steps 4 and 5 until there are no coefficients left underneath the division symbol. And if you have a remainder, that's fine. That's fine. You'll notice that the quotient of a polynomial is always 1 less than the dividend with coefficients of the numbers in the third row. And the last number in the third row is going to be your remainder. So, a special note is if you do have a remainder of 0, that means the divisor was actually a factor of the dividend. So this is kind of a neat way to check to see if something is a factor of a larger polynomial. But you could only check factors that are of the form x minus c. So this is the first example. I'm going to fix this where I can write on it. I think I can now. Let's try it out. There we go. All right. These are already in descending order from highest degree to lowest, so we're okay. We have x to the third, we have x to the second, x to the first, x to 0. We're okay. Now we write the coefficients. The coefficients are 3, 2, -1, and positive 3. Then you take your c value. Remember, this is x minus c, so c is 3. You place it right here. Now, the reason we call this synthetic division is because it is not your typical long division. You're not going to follow the same rules as long division. Here's what we do. Remember, the step was to bring down the first number. You multiply the last entry that's in the third row. This is the first row, second, and third. Just in case you're wondering which row is which. Third row, you will multiply the last entry in the third row by the coefficient and place it below the next coefficient. So I think I should have said multiply it by the divisor. There's no telling what I said. All right, anyway. 2 plus 9 is going to be 11. Now we do the same thing again. 3 times 11 is 33. Combine these together, you get 32. 3 times 32 is 96. You combine those together and you end up with 99. So, when we take this polynomial and we divide it by this divisor, we end up with 3x to the second. Notice how I dropped the degree by 1. This was third degree. This will be the answer will be second degree. Plus 11x plus 32 with a remainder of 99. Now remember, we can take the remainder and we can write it as a fraction. So 99 over x minus 3. Now, what was said in the notes before is that if you take this x minus 3 and you multiply it by the answer, the dividend, no, the quotient, sorry, and then add the remainder, it should come out to this right here. It's kind of hard to believe that all these big numbers are going to come out to that, but let's work it out and find out. You don't have to do this on the homework. I don't want you to check all of them, but I'm going to check this one just because I'm kind of a little curious about the numbers coming up so big. And who knows, I may have made a mistake. X times 3x squared is 3x to the third. X times 11x, 11x squared. X times 32, 32x. Negative 3 times 3x squared is negative 9x squared. Negative 3 times 11x is negative 33x. Negative 3 times 32 is negative 96. And if we add on the 99 we will have 3x squared, cubed, sorry about that. 11x squared minus 9x squared is 2x squared. 32x minus 33x is negative 1x. And negative 96 plus positive 99 is positive 3. And it's identical to the original dividend. Neat stuff. Now I'm going to work another example. This one you'll notice has x plus 3. So it'll show you what to do when it's not looking identical to x minus something. First thing we do is we write these in descending order, and they are. We write the coefficients in the divide symbol. 1 is x to the third. 0 would be x squared, because there's no x squared term. The linear term, the x to the first, is 2. And there's no constant, so I'll put a 0 for the constant. Now, remember, x minus c. Well, because this is x plus 3, that means c would have had to have been negative 3 to be able to achieve that plus 3. So c is negative 3. I bring down the first coefficient. I'm going to multiply and write it right below the second coefficient. Now I'll combine those together, and now I'll keep doing that. Multiply, combine, multiply, combine. So my answer turns out to be, this is third degree, so my answer will be second degree. 1x squared minus 3x to the first plus 11, and then we have a remainder of negative 33 over x plus 3. That's it. Whole lot quicker, whole lot simpler than having to do long division. The only thing is you're restricted to having to have a 1x. You can't do it if there's a coefficient other than 1 on the x.